B and D will be represented by a line. Now as I need to go right, so assuming in the using the same concept what we have done in the last video. So as I reach point B, I have to take right. So I've asked you to assume the positive as your front wheel and the my negative as your rear wheel. So as I take right, so the positive will be towards point C and negative will be towards point B. Similarly, when I need to take left, positive will be towards A and negative will be towards B. So you can shift either towards positive or towards negative side. That is either towards point B or towards point D. And after shifting, the voltage source will be represented as short circuit and then shifted, and the values would be same as its magnitude, 18 volts each. Next, current source 2 amperes. As you can see, between point D and point C, it's an ideal current source. It's not a practical current source. Thus, we can shift it also in the same step. So point C it is entering and point D it is leaving. So let's start from point D. So point D it leaves and it enters point A, and point A it enters. Now it leaves point A and enters point B, enters point B and leaves point C. So still 2 amp is entering. You might wonder, sir, it has entered point A, it has also entered point A and B. So isn't the electrical characteristic has changed? No, the electrical characteristic has not changed, because according to KCL we know current entering is equal to current leaving. All the current entering is equal to all the sum of all the currents are leaving, or sum of all the current at junction is equal to 0. So this 2 amp is entering at point A and the same 2 amp is also leaving at point A. So the effect of this 2 amps at point A or point B is nullified, whereas point C exists because it is still entering. Thus the electrical characteristics remains intact or remains same to the previous condition, right? So now in this step I am converting this 18 volts to 2 ohm. The main reason behind this is so that I have 5 elements in parallel. So I wanted to pause and analyze which are those 5 elements that are appearing in parallel if I convert this voltage source 18 volt into 2 ohms, which is practical voltage source, to a practical current source. There are 5 elements. Which are those 5 elements? 6 ohm, 2 amps, 9 amp, 2 ohms and 2 amperes. All these 5 elements are in parallel. So in parallel we can reduce to one equivalent current source and one equivalent resistance. Now if you see 2 amps, they are in opposite direction. One is going towards point B and the other is going towards point A. Thus they cancel each other and the total current remains 9 amperes. And then 6 and 2 ohms are in parallel, thus they become 1.5 ohms. From here how do we solve? And what is this line B and D? It's just a line, you can neglect that. So what I'm doing next? So I'm converting this practical current source to practical voltage source. The reason behind that is I can incorporate 6 volt in series. So you can see the arrowhead is towards point A, so positive will also be towards point A, and the tail is towards point B, so negative is towards point B, and these two branches will become one branch as it is a practical current source. So we know V is equal to I into R. 9 into 1.5 is 13.5, and then the resistance 1.5 will be in series to the voltage source. Now thus 6, 13.5 and 1.5 are in series. Now 6 volts and 13.5, we can add or subtract, right, the voltage source in series. But here what is the right answer? What should we do? Should we add or subtract? Here we have to subtract the voltage sources. Okay, if you're not sure how, you can go back to the previous videos and then analyze. It becomes 7.5. Now I'm trying to redraw the circuit. You can see point A and point C both are now same. I repeat, point A and point C are same as we use an external wire to connect. And point A is being positive or point C is also being positive. The same thing is written here. And current 2 amp is entering point C. 18 volt positive is also seeing point C. Thus rewriting the circuit in this way, what could the next step be? Or you can try to solve from this step and then check your answers also. Now I would say I'll convert 7.5 and 1.5 into a practical current source The reason behind this is I'll have a current source which will be in parallel to 2 amperes, thus I can reduce the circuit. Right? So 7.5 and 1.5 ohms. I is equal to V by R. 7.5 by 1.5 you get 5 amps, and then 1.5 would be parallel to your current source. Thus 5 and 2 are in same direction. We'll add and represent that as 7 amperes. Now how do we solve? Now please remember, in every step we have not used 3 ohms at all, because that is what we must find. Across 3 ohms we must find voltage, so do not touch that element until end. So keeping that in mind, we'll convert now 7 amp and 1.5 ohms, 7 amps and 1.5 ohms into a practical voltage source. Okay, and you can see the arrow is towards point C, thus the positive terminal is also towards point C. So wherever is the arrowhead, you'll have positive, wherever is the tail, you'll have negative. So V is equal to I into R, 7 into 1.5 is 10.5. Now you can apply KVL and solve. But what I have done here, 10.5 and 18, 3 and 1.5 all are in a loop and they are in series. Thus voltages can be added or subtracted. Now in this case, should you add or subtract? Now in this case, you must subtract. How? If you have filled out, go back to the previous videos where we discussed on voltages, how do we add and subtract, and then you can come back and check here. Thus the answer here is 7.5 volts. And how do we analyze the polarity? Again, go back and check the previous videos. And the voltage is 7.5, and by voltage divider, main voltage is what? The main voltage is 7.5 into same resistance divided by sum of the resistances. And whether the voltage is positive or negative, to analyze that, the current coming out from 7.5 volts will actually hit the positive terminal of 3 ohms. I repeat, then in the loop, the main voltage is 7.5 volts. And how is the current coming out practically? So practically the current is coming out from positive terminal of 7.5, and that current will hit the voltmeters positive, which is connected across 3 ohms. Thus it would be positive, and thus this answer is correct. And if you think it's -5, it is wrong. It is +5. So thank you for watching the video. So please do subscribe the channel and watch all the videos to enhance your knowledge.